Dobre dzin. Well, that's the way we say hello in Belarus. Hello, children. How are you people doing? I'm Saurabh Kumar Dutt, and I'm here to teach you people a little bit about area theorems, about areas of parallelograms and triangles, and how they can be proved to be equal if they are on the same base and between the same parallels. Here we will also be looking up a special relation between the areas of parallelograms and triangles. Then I will tell you how you can stop yourself from losing even half a mark from the board examiners when you do sums on geometry. I will also be discussing a special sum which is highly probable for your examination, so make sure to first try it well when I give you a little time, and after that when I discuss the solution, do look it up. Also look up the second explanation that I give you, in which I give further insights. And after you've done this, make sure to try out the sum once more, so that if a similar sum comes your way, you're able to do that with ease. Now, before I start off with all of this, I'd like you people to be teleported with me to this place where I intend to take your class today. This is a historical tribute to the Belarusian tenacity against the German intrusion during the Second World War. Here, do take a walk inside the terrace pole gate, where you will see inscriptions made by the dying soldiers bidding farewell to their dear ones. Here you can take a boat ride on River Mukawets, which is a tributary of River Bug, and you will see it meet River Bug here itself in Brest City, Belarus. When you're here, make sure to have Bankuchi, the famous sweet delicacy of this place, and you'll be mesmerized by it. Make sure to tell all the people of Belarus that you get to meet Dobre dzin. And in this note, children, I will again say Dobre dzin, but at this time it will be to area theorem, to parallelograms and triangles, the topic that we are going to discuss at this time. So children, when we talk about this theorem, right, I'm sure you all know what parallelograms are. So first I'll make a parallelogram to make you people understand what actually parallelograms are. These are actually quadrilaterals which are having two pairs of opposite sides to be equal and parallel. This is the perfect definition of a parallelogram. So this is a parallelogram which has one pair of its opposite sides to be parallel. Like I told you, they are also equal. And here you have the second pair of opposite sides which are parallel as well as also equal. Now, when you have such a quadrilateral, if you have another quadrilateral of this type, which say is on this base, that is CD, and is between the parallels AB and CD, then they have the same area. For that matter, now if I try and enhance this length AB to say a little more, going up to F, right? So here you can see that this is actually being extended to go up to F. And now here, if you talk about another parallelogram which is going to be made on this, like this, that first say we talk about this to be one line which makes a side, and then we will make another such line like this, right? So here let's say we make such a line which is actually parallel. Here this is not becoming a line which is parallel, so we will have to make a line which is parallel. So let's say now parallel to this I make a line like this and say that this is another parallelogram. So as both of these are on the same base CD and are between the same parallels CD and AB, both of these parallelograms which are ABCD and let's say GHDC will be equal in area. So I will write this: parallelogram ABCD will be equal in area to parallelogram GHDC, right? So this is by area theorem, right? Now this actually has a very simple proof. Now if you talk about the area of a parallelogram, it is equal to base into height, and since both of these parallelograms have the same base CD, so obviously the length will be the same of the base. And if you talk about the distance between two parallel lines, it is fixed. So when we talk about the perpendicular distance between these two parallel lines, that is actually the height of this parallelogram, and that also being equal, so the areas of both of these parallelograms is to be equal. Now after this there is another theorem, that is, if say now we talk about a triangle which is on the same base CD and is between the same parallels, that is AB and CD, then its area will be half the area of the parallelogram. Again, to prove this is also pretty simple. We can consider this point to be, say, some Q. So we can now say that area of the parallelogram ABCD, if you half it, then you will get the area of the triangle QCD. Why is it so? Because whenever you talk about the area of a triangle, that is half into base into height. So as here we have the base to be CD and the height is also the same, so whatever is the area of the parallelogram, if you half it, you will get the area of the triangle, right? So all of this that I told you people, I will quickly repeat. Now the first thing that I told you people was about the area theorem getting applicable to parallelograms who are between the same parallels and have the same base. So if say we have a parallelogram which is ABDC, right, and here let's say if we talk about another parallelogram which is on the same base CD and is between the same parallels CD and AB, where now we have the vertices to be G and H, such that these two lines GC and HD are parallel to each other. So this again forms another parallelogram, and both of these parallelograms will be equal in area because they have the same base and are between the same parallels. That actually comes from the fact that the area of a parallelogram is base into height. So as the base is the same in both the cases and the height, that is the perpendicular distance between both the parallel lines, is also the same, so thus the areas of ABCD and GHDC will also be equal. Now after this there was another theorem which linked the area of a parallelogram with that of a triangle. So if there is a triangle which is on the same base and between the same parallels, obviously the base length will be the same as the parallelogram and its height will also be the same as the parallelogram. So half into base into height gives you the area of the triangle, and thus if you half the area of the parallelogram ABCD, you will get the area of the triangle which has been formed QCD on the same base and between the same parallels. Now children, there is another thing which is added, a corollary, that is, if you talk about triangles which are on equal base and between the same parallels, even they have the same area. So let us now, to do this, extend this line a little, that is CD a little more, and let us take it to a point PC. Now if we form a triangle which is, say, on a length which is equal to CD, let's consider here a point which, say, is some Z, and let us now form a triangle out of this. That is, let us now draw two more lines so that we can join this point Z to be a triangle such that it is between the same parallels AB and CD. So here now we are going to form this triangle, that is this triangle which is here, is triangle HZP. Its length, that is, if you talk about the length of ZP, if it's X, then this length CD also is equal, that is, it is also X. So if such is the case, then area of the triangle HZP will be equal to area of the triangle QCD, as they are on equal bases. They are not on the same base, but they are on equal bases and between the same parallels. Similarly, the area of the triangle HZP will be said to be half the area of the parallelogram ABCD, as again it has the same area with the triangle QCD, and area of QCD was half a parallelogram ABCD, so area of triangle HZP will also have the same characteristic. Did you all understand? So even triangles which have equal bases as the base of the parallelogram, they will have half the area of the parallelogram if they are between the same parallels, right? So having said all of this, now we have to prove a question. So initially I'll give you people a little time for trial, some 10 seconds, as you people are normally offline. Shefali, remember, do give this a bigger try, because these questions are actually for you to be able to understand and apply the concepts that you've learned. You should not directly try and see the solution, as seeing the solution makes you people defeated. That means I won't be able to do the sum. That's why I'm looking up the solution. So make sure that you first try out the sum, take some more time by pausing the lecture, and then after you either not been able to do the sum, or even if you've been able to do the sum, do look up the solution, how actually do, and be saying this, that I've been able to do the sum. Do comment me also whether you've been able to do the sum before you looked up the solution, right? And after you looked up the solution, make sure to do the sum once more all on your own, and try and find questions of the same type, although I will also provide you a question at the end of this lecture in the description of the lecture, where I require you people to do that sum and also send me the solution in my email ID, which will be provided in the description, right? So let's get started and let's do this. Okay, so the sum before you is this. I'd like you people to initially try this. I'll give you people a little time for trial, after which I'll be discussing the sum. Shefali trying? Good. Now you understood the theorem perfectly? Yes? Good. Okay children, now let's discuss the sum. I am taking this into consideration that you have tried out the sum really well, right? You paused the lecture, you've taken all the notes of what all I said and put them into action for this sum and try out the sum really well. Okay, so in the question children, you've been given here, if PQRS and ABRS are parallelograms. So let's quickly look it up, which are the ones which are in question. PQRS. So this is one parallelogram, so we will mark it so that we can see which are the parallel sides and which are the equal sides. So as you know that both of these opposite sides are going to be equal and parallel, so we've marked it. Now the second is ABRS. So AB, that is 1, right? And RS is this. So if we talk about this ABRS, so this is the second parallelogram. So here children, as we've been given that this is also a parallelogram, so we can easily say that this straight line AS is going to be parallel to this straight line, which is BR. Okay, and having said that, obviously these two sides are also going to be equal, right? Now you've got to show that the area of the parallelogram PQRS is equal to the area of the parallelogram ABRS, right? So both of these, as you see, have been given to you on the same base SR. Now let's talk about the first parallelogram. We have it to be SRQP, right? And this parallelogram has the base SR, right, and is between the parallels SR and PQ. And if you talk about the second parallelogram, that is ABRS, it is also on the same base SR and is between the same parallels SR and PQ, as PQ has been extended up to B, but it remains to be the same line. As such, it is between the same parallels. So here, children, remember, like I told you, I will tell you how to do the sums in geometry. They will be done like statements and reasons. So on the left hand side, you'll be writing statements, as you normally see is written in theorems. And then on the right hand side, you'll be writing the reasons for which you did something, right? So point number one is that we have area of the parallelogram, which is PQRS, which can be said to be equal to the area of the parallelogram ABRS. And here, as reason, you will state both parallelograms. It's better you write parallelograms in your copy, right? Here I am writing an abbreviation. So both parallelograms are on same base, which is what? Which is SR. And are between the same parallels. That is, one is SR and the other is AB, right? So as such, by area theorem, the areas are going to be equal. So this is how much you require to write, right? But the way that you write is something which is very important. That is, on one side you're going to write the statement, that is what you're doing, and on the other side you require to write the reasons why you're doing this, right? Okay, now we come to the second part of this question, which asks us to show that the area of the parallelogram PQRS is equal to half the area of the parallelogram PQRS is to be shown to be equal to the area of triangle AXS. Now A is here, X is here, and S is here, right? So if you talk about this triangle AXS, here it is on this base AS, right, which is of the parallelogram ABRS, right? And now it is between the parallels AS and BR. So obviously its area will be equal to half the area of ABRS. We can say this, right? So now here we're going to say this, that first point is, now here, for what were you doing this? You were doing this for area of parallelogram ABCD is equal to area of parallelogram ABRS. You were doing this. This was point number one. Now we are doing it for area of the triangle AXS, right? That's equal to area of the parallelogram, rather half times of area of the parallelogram PQRS. Now here, children, the first statement is going to be this, that area of triangle AXS will be equal to half the area of the parallelogram ABRS, right, which is what I showed you just now, as ABRS is a parallelogram, right, and AXS is another triangle. This triangle is on the base AS, and the parallelogram can also be said to be on the base AS. So here we will say this, that this is because both are on same base, that is AS, right, and are between the same parallels. Which are the same parallels? One is AS and the other is BR, right, as they are on the same base and are between the same parallels. So the area of the triangle will be equal to half the area of the parallelogram, a theorem that we discussed earlier before doing the sum. Okay, now here next you will say that as you have the area of the parallelogram ABRS to be equal to the area of the parallelogram PQRS, so in place of ABRS you can replace PQRS. So here we can mark this to be equation number 1. So here you will say that area of triangle AXS is equal to half the area of the parallelogram PQRS. Here you can say that by equation number 1, area of parallelogram PQRS is equal to area of parallelogram ABRS, right? So therefore this stands to be proved, right, and we prove this by area theorem. So if you do it this way, no examiner will be able to cut any marks, because you are writing the statements and you're also writing the reasons, which are actually theorems, right? So I'll just quickly explain this to you once more. In the question, children, we've been given here that there is a figure in which you've been asked to show that the area of the parallelogram PQRS is equal to area of the parallelogram ABRS. And before doing so, you had been told here that PQRS is a parallelogram and ABRS is also a parallelogram. That is, PQRS is a parallelogram. That means its opposite sides are parallel and also equal. Its opposite sides are parallel and also equal, right? Then for ABRS, we had the opposite sides to be already parallel, right? But this length AB is also equal to SR, right? And why is this already parallel? Because actually QB is an extension of the line PQ, right? Further, if you talk about the other pair, that is AS, it will be parallel to BR and also equal to it, right? We will use these when required. For the time being, when we've got to prove both of these parallelograms to be equal in area, we see that we have the first thing, that is the parallelograms are on the same base SR, right? PQRS on the same base SR and ABRS again on the same base SR. So this is the first thing that we can say, that both of these parallelograms have the same area because they are on the same base SR, right? And the second thing is that they are between the same parallels. For the first case, PQRS, the parallels are PQ and SR, And for the second case, A, B, R, S, the parallels remain to be the same. That is, we can say that it is PQ and SR, right? So this is what we say between the same parallels, SR and AB, right? So here one is said to be SR and the other is said to be AB. You can even say that it is PQ, right? And as that is the case, thus the areas of both of these parallelograms are equal. That is the first thing, and it has now been proved by the area theorem. Now the second part is that we've got to prove the area of a triangle given to us, that is AXS to be equal to half times area of the parallelogram PQRS. So in order to do that, what we've done is we've considered the parallelogram ABRS, and AS is being considered to be its base. So this triangle is on the base of the parallelogram ABRS, that is AS, and is between the same parallels AS and BR. As you can see that its vertex X is on BR. As such, its height will be the same as that of the parallelogram ABRS, taking AS as the base, right? So thus we can say here that the area of AXS is equal to half the area of the parallelogram ABRS, as both are on the same base. What is the same base? AS, right? And are between the same parallels AS and BR. This is AS and this is BR, and that is true for the parallelogram as well as for the triangle, right? And thus their areas are such that area of the triangle is half the area of the parallelogram. Now, as we already proved that area of parallelogram PQRS is equal to the area of the parallelogram ABRS, thus in place of ABRS, now we can write the parallelogram PQRS, that is by 1, that we've already proved. And this is what we say, that by 1, area of parallelogram PQRS is equal to area of a parallelogram ABRS. And thus the second thing also stands to be proved. So is everybody clear about this, Shefali? Sure. Any confusion about the two area theorems? Yeah, there are two area theorems. The first is parallelograms which are on the same base and between the same parallels are equal in area, right? So even if you have a rectangle which is on the same base and between the same parallels, then its area will also be equal to the area of the parallelogram on whose base it is and is between the same parallels, right? Now the second is area of a triangle which is on the same base or equal base and between the same parallels will be equal to the area of any other triangle, or it will be equal to half the area of the parallelogram on the same base and between the same parallels. These are the two theorems, Shefali. Clear? Okay, so this is all that was there in this lecture. I hope you've been able to understand this. This is a question which has much probability of coming, and questions like this are normally asked in your board examination. And if you do the sums like statements and reasons like we did here, I'm sure you will be able to get good marks, and teachers won't be able to cut any marks from your answer sheet. So children, do it this way. Do a practice of the sum that I just discussed to make it perfect, right? There's a question which will be there in description. Do that sum and send it to me in my email so that I can see and correct it. Moreover, do write a simple message, right? That is a comment as to what all you learnt in this, and when you've written it, obviously I will get to understand that you've actually learnt and understood this, and when you write it, obviously that will help you in memorizing it also. So do write as much as you can say about the area theorems and about the sum that we've done and the way that I've discussed, whether that is understandable to you or not, something more that you want, anything that you want me to discuss in concepts, right? Do write even about that so that I can get back and make lectures for you people so that you people can be properly helped. Moreover, if you have more doubts and want with me a personal session, then there is a link to which you can click and write, and obviously I'll get back to you, have a personal session, and I'll be sure to help you out, right? So bye children, have a nice time, do study maths, practice, and keep enjoying. Bye.